All right, this is Honors Algebra 2 Pre-Calculus. We're doing 4.6 in Pre-Calculus, which is graphs of other trig functions. In this video, we'll focus on secant and cosecant, and then we'll focus on tangent and cotangent in the next video. So recall that secant is 1 over the cosine of x, right? So cosine of x is in the denominator. What that means is that secant will have a vertical asymptote, one of those invisible dotted vertical lines, wherever cosine of x is 0. Now, when we start doing transformation on our functions, so in a regular cosine graph, that would be on the x-axis where cosine is 0. But when we start doing graphs with transformations, changes in sea level and amplitude and period and all that stuff, what that's going to mean is it's going to be wherever the cosine of graph is at sea level, right? And we can say the same thing about cosecant and 1 over sine x. So we're looking for where sine x would be 0. But again, in a transformed graph, that would be whenever my sine graph is on sea level, right? That middle line. So basically what we're going to do is we're going to graph the cosine or the sine graph that corresponds with the secant or cosecant that we're given, sort of as an invisible like dotted line graph, right? And then we're going to draw the secant and the cosecant as though they're kind of the hats and the shoes, which I know sounds super weird, but you'll see what I mean, on top of the cosine or sine graph. So let's go ahead and walk through this. So here's the graph of cosecant x, okay? So you'll see that this dotted red line, right, this dotted line, this is the sine curve, right? So this dotted curve is the sine curve. And what you'll see is that there are vertical asymptotes anywhere sine would be 0, which is at all the pi's, right? So like 0 pi, 1 pi, 2 pi, negative pi, negative 2 pi. So there's these green vertical asymptotes. And then what's going to happen is that this purple curve that you see, these pieces that look like little U's, right? Upside down or regular U, right? Those are the actual cosecant graph. So the cosecant graph is actually in purple. And when I say it's the hat and the shoes, basically what I'm saying is here's my sine graph. Right at the top of sine graph, there's a little hat, right? And it falls between those two vertical asymptotes. And down here at the bottom of the sine graph, oh, there's the shoe, and it falls between the two vertical asymptotes. And then there's another hat and another shoe. And again, I know that's kind of a weird analogy, but that's the idea. Now, what I want you to notice is that the domain of this cosecant graph is basically every number in the whole world except for these vertical asymptotes. So the way we're going to write that is x is an element of reals, but x can't be n pi, where n is a whole numbered value of pi, right? Like a plus or minus, and so an integer value of pi, right? 0 pi, 1 pi, 2 pi, negative 7 pi, any of those. And then you'll notice that the range is from here up and from here down. So the range is basically from negative infinity, which I can't include, to negative 1, and then skip all the way up to 1, and then from 1 to infinity. Okay, so it's essentially the exact opposite range of the window you'd see for a sine, right? So sine falls between these two, and cosecant is above and below that value. And the period is 2 pi, the same way it was for sine, because you can see that it would take this, oh, sorry, my bad, that it would take this amount of time to repeat the graph. That's 2 pi, right? So that's the original graph. All right, so moving on. The secant graph's the same basic deal, except you can see that this dotted blue curve is the cosine, and so then the secant is the hat and shoes on a cosine graph. Because cosine is 0 at all the pi over 2's, right, specifically the odd numbered pi over 2's, right, like pi over 2, 3 pi over 2, 5 pi over 2, but not 4 pi over 2 because that would be 2 pi, right? So all the odd numbered pi over 2's, which is how I wrote that 2n plus 1 is the way you write an odd number because 2n would be even, so 2n plus 1 is odd. So all the odd pi's, there's going to be this yellow vertical asymptote, and then we draw the hat and the shoes, right? So let's go ahead and walk through a couple of examples of doing this. So we're going to go ahead and graph 2 secant x plus 1. So what I'm going to do is I'm actually going to graph the corresponding value, y equals 2 cosine of x plus a 1. I'm going to graph this as a dotted curve, and then I can draw the hat and shoes on it. So here's what I know about this. I spot that the amplitude, so the absolute value of A is the absolute value of 2, or 2, that's my amplitude, right? I spot that sea level is at a positive 1. And then everything else is pretty normal. The period is 2 pi over 1 because there's no number in front of x, so it's just 2 pi. So when I go to graph this, my sea level's up at 1, so there's 1, and that'll be my sea level, right? And then I'm supposed to have an amplitude of 2, so I would go up 2, and that would be the top level of this cosine curve, right? And I'd go down to 1, 2, and this would be the bottom level, okay? So again, all of this is to draw the curve that's not actually the curve I want, which is kind of crazy, but you get the idea in a minute. So 2 pi is the period, and then I can cut it in quarters, right? Cut the 2 pi in half and cut the halves in half, and the same thing on the other side. Cut it in half, cut the halves in half. So the dotted line, the cosine x, right? Cosine starts up, so the dotted line is going to look like this. Up, middle, down, back to the middle, back to the top, right? And then same thing here, right? At the first hash mark, it'll be at the middle, then down at the bottom, back to the middle, and back up. So this is the cosine graph, right? But that's still not the graph I actually want, right? So which is kind of crazy, but this is still not the graph I actually want. What I know about this, and I'm going to go ahead and graph my, I'll go ahead and graph my secant in green, is that anywhere that this cosine is at sea level, I'm going to have a vertical asymptote. So all these spots where we have a sea level, I'm going to have a vertical asymptote. I'm going to go ahead and draw those vertical asymptotes in. And then once I have those asymptotes, in between the asymptotes, I'm going to go ahead and take at the top point and draw a U. Now I'm only drawing half the U. Technically it does go over to here, but like this is all I need, right? Like I could stop there. Down here I'm going to draw this shoe, right? The upside down U, right? Up at the top I'll draw another hat. And notice that the point that they share in common is that very top point that happens at 1, right? And so the green curve, right? The green curve is my secant curve. And again, you can finish out this U over here if you want, just like I did over here, right? Like you don't have to. That's not what we were asked to do, right? We were only actually asked to graph 2 full periods. This is actually more graph than you need, right? Like you could stop there. But that's the idea. So notice all the blue stuff is just work to get to the green stuff. So the green is my answer. But the blue is how I'm able to graph it accurately without a calculator, right? And you can see that if we go to mode and make sure that I'm in radians, which I'm probably not because we were doing word problems the last time I was on the calculator. If I go to y equals, when I want to graph a secant, that's going to be 2 divided by cosine, right? Because it's 2 secants, so that's going to be 2 divided by cosine of x, or 2 times 1 over cosine, which is the same as 2 divided by, and then plus a 1, right? If I wanted to set this window up, you can see that here, right, this is a 1, 2, 3. So I would set my window so that my y values, let's just say my y values can go to like 5, that's fine. And I could do like a -5 for my y values, that's fine. And then for my x's, I would actually want to go by pi's, right? So my x, I would do a -2 pi. And I would do a 2 pi, just to show you that this is what the graph would look like. And then I would go by, if you cut this in half, you get pi's. Cut it in half again, you get a pi over 2. So I would go by pi over 2's, just to show you that this is the same graph. And it'll be a slightly different window than what I have, but there you have it. So you can see that's what it looks like on a calculator too, right? All right, so let's go ahead and you try one. So again, in blue, we're going to graph the sine function that would correspond with this, right? So what we're going to do is as a dotted line, you're going to graph y equals -3 sine of x plus 5, right? Now, that's not to say that some of you can't do this in your head and not actually write the dotted lines, and that's totally your business, right? So first thing I notice about this is that the graph is a negative sine of x, right? That's the thing I'm graphing, right? So negative sine starts in the middle and goes down, right? So starts middle, if this is the top line, middle line, it goes this way, right? So starts in the middle, it goes down. Second thing I notice is that my amplitude is a 3. And the third thing I notice is that my sea level is at a +5. So it seems to me that I'm going to have to go up to 5, and then from 5 I need to move up and down 3 units. So 1, 2, 3, 4, 5. 1, 2, 3. So there's up 3, that's the top, right? And here's my 5, which is sea level. And down 1, 2, 3 would be at 2. Right? So those are my values. Right? I noticed that I didn't change the period here because the period is 2 pi over 1. There's nothing in front of the x, so it's just 2 pi. Right? So my period is -2 pi on this side, and the other period's a 2 pi on this side. And I cut that in half, and I cut the halves in half again. Cut it in half, cut the halves in half. All right. So I know a negative sign starts down, right? So what that's going to mean is, starts in the middle, and then it goes down. So a negative sign starts in the middle and goes down, and then back to the middle, and then up, and then back to the middle. And notice that is definitely 1 full period because I both started and ended at the middle. That's a full wave, right? And if I do the same thing in the other direction, this hash mark I'm going to be up, back to the middle, all the way down, back to the middle. And again, that's a full wave, right? So anywhere that I have, anywhere I'm at sea level is going to be a vertical asymptote. So if I go ahead and put this in green, there's going to be a vertical asymptote here, right? Anywhere I am at sea level, right? So anywhere I'm at sea level, there's going to be a vertical asymptote, and here, and here, and here, okay? And then what I'm going to do is I'm going to go ahead and draw the hat and shoes. So if I've got this bottom point, I'm going to go ahead and draw inside the asymptotes. I'm just going to draw a little upside down U. There's a shoe, right? Up here there's a hat, right? And again, the easiest way to do it is to start at the point that they should share and then just draw your U going in both directions, right? And then up here, start at the point they share and draw that hat. And there you go. So my answer is in green again. Now, if you're doing this on a test and you might have to label it as a little tough if you're not using multiple colors. One easy way to do it, again, if you didn't label that as the answer, I would assume that these solid curves were your answer and the dotted lines were just work, which they are. So, all right, so let's do one that's a little bit harder. So there's some more changes here, right? So this time we're looking at a change where we also have a period change, right? So the thing I'm going to graph, right? The thing I'm going to graph as a dotted line is 4 sine of the quantity 2x minus a 3. So first thing I notice is that it's a positive sine graph, right? So positive sine graph starts in the middle and goes up, right? So if this is the middle and the top and the bottom, it starts in the middle and goes up to the top, right? Second thing I notice is that the amplitude is the absolute value of 4, which is a 4, and that my sea level is a negative 3, right? So I'd start down at negative 3. And then the last thing I'm going to notice is that the period is going to be 2 pi over 2, which is a pi. So that's the only other big difference. So let's go ahead and put my sea level on. So that's negative 3. What? 1, 2, 3. There's my negative 3. That's sea level. And then once I'm at sea level, my waves are supposed to be 4 units in either direction. So I go down 1, 2, 3, 4. That's the bottom. And I go up 1, 2, 3, 4. Now this is going to be one of those where that top line is very close to the axis, so you have to be careful to not put your dot on the axis by mistake. My period is a pi, so I'm going to put a pi on either side, and then I'm going to cut it in half and cut the halves in half. Cut it in half, cut the halves in half, right? And then once I've done that, I just need to go ahead and graph my sine, right? So sine is going to start in the middle, and at the first hash mark, it should go to the top, right? Back to the middle, to the bottom, back to the middle, right? And then over here, same thing, I'm going to follow the same pattern. Bottom, middle, top, back to the middle. And you can see that graph does have a full period because it starts and ends at the middle each time, right? We can get that wave. So then anywhere that so again, we'll do this in green, anywhere that my graph is at sea level, that's going to be a vertical asymptote. So there's going to be a vertical asymptote right here. There's going to be a vertical asymptote right here. Again, forgive my inability to draw well. There's a reason I did not become an art teacher. So, cool. Right, so once we have that, anywhere there's this top dot, right, at the top of the crest, I'm going to draw a hat, right? The next window is the bottom of a valley, right? So I draw a shoe, top of a crest, draw a hat, bottom of a valley, draw a shoe, just stay in between those vertical asymptotes, and that's close enough, and there you go. And you can see that if I were to graph this, right, this would be a 4, and then instead of being a cosine, it's a sine, right? And then 2x is inside sine, right? And then a minus 3. So now when I go to my window, the thing to notice is that my period has changed. It's not a 2 pi, it's a negative pi, my bad, pi. And this one's also a pi, so second pi, right? And then I cut pi in 4 pieces, so this is actually a pi over 4, right, if you were going to change your window to match what you just graphed by hand. It seems to me like my y value should probably go down like as low as maybe a negative 10, right, because it seems to go to like a negative 7. And I'd say going up to a 5 is just fine. So if we graph this, you'll see that that's the graph that you get, same basic graph. All right. So we're going to do one more like that, and then we'll do one more example. My guess is that I included a phase shift, but we shall see. All right, so again, what you're going to graph as a dotted line, right? So what you're going to graph in a dot, right, is y equals negative 10 cosine of 8x quantity plus 5, right? So first thing I notice is that this is a negative cosine graph, which means it starts down, right? If you look at a cosine, cosine starts down, right? So starts down. Sorry, negative cosine does, so it starts down. Positive cosine starts up. Second thing I notice is that the absolute value of negative 10 is 10, and that's the amplitude. So I'm going to need a pretty small scale because that's a big amplitude, right? Third thing I notice is that my sea level seems to be a plus 5. And the last thing I notice is that the period seems to be 2 pi over 8, which is a pi over 4. So when I go to put all this stuff on my graph, right, let's make the pen narrower. All right, so we need to go up to 5 to start. So 1, 2, 3, 4, 5. That's 5, so that's going to be my sea level. And then I need to have room to go up 10 units and down 10 units. So up 10 units is the harder one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's going to be the harder one. And keep in mind that because this is a secant graph, I'm going to have something above that when I graph the u's, right? So here I go down 5 to get to the axis again, and then 1, 2, 3, 4, 5. And there's my other dotted line, It's not perfectly symmetric, but that's okay. So I've done my amplitude and my sea level. I now need to put a period on either side of the y-axis, right? So I've got pi over 4 and a pi over 4. Cut it in half, cut the halves in half, cut it in half, cut the halves in half. So when I graph this, it's a negative cosine, meaning it starts at the bottom. Then it's going to go up to the middle and all the way up to the top, and then back to the middle, and then all the way down to the bottom. And I do the same thing on the other side. So middle, top, middle, down, right? And again, it doesn't have to be the prettiest graph you've ever seen. Certainly graphing well is not my forte, but that's okay. And then I'll go ahead, oh, didn't mean to do that. We'll go ahead and pick, we'll pick a different color this time. We'll do red. So wherever the cosine graph is at sea level, that's where there's going to be a vertical asymptote, and I kind of missed, but that's all right. So vertical asymptote here. Oh, my bad. All right, vertical asymptote here and vertical asymptote here. Again, it doesn't have to be the prettiest graph you've ever seen, right? Anywhere that there's this bottom at the bottom of a valley, we go ahead and draw the shoe. Now that's only half a shoe. You could technically go the other way as well, but in this instance we weren't asked to because it was just 2 full periods, right? So hat, down at the bottom I have a shoe, right? And again, it starts at that same point that is at the bottom or top of the cosine curve, right? So hat, and then down here I'll have half a shoe, and you'll notice it is still 2 full periods because this half a shoe and this half a shoe together mean that we started and ended at the same spot in a period. All right, so I'm guessing I threw a phase shift in. Hey, look at that. Surprising, I actually was able to anticipate what I threw at us. So I'm going to go ahead and graph this. It has a phase shift. So notice that there's no change in amplitude and there's no change in sea level. So like the amplitude is just 1 and the sea level is just 0, right? So that's like boring and standard. What makes this tricky is that there's going to be a phase shift, right? So what I'm going to graph is I'm going to graph cosine of 4x plus pi, right? And like I said, I see that these are the same already, nothing weird about them, and I see it's a positive cosine graph. So the entire thing is figuring out the period is 2 pi over b, which in this case is going to be pi over 2, right? And the phase shift, c over b, is going to be a pi over 4 to the left because it's positive, right? Because it's a positive pi over 4. So if we go ahead and put the period on here, right? So there's a period at negative pi over 2. The full period is at pi over 2. Cut it in half. Well, that's going to be a pi over 4. And then cut the halves in half. So cut it in half and cut the halves in half. So this means left 2 hash marks. And that's going to be the entire thing. Like I just need to move my start left. So start is now going to be here. If that's new start, right? When I go ahead and put up at 1 and down at -1, that's going to be my top and bottom, right? Because again, it's easy to forget, but that's what happens if sea level and the amplitude aren't changed, right? So that's my top and bottom. So instead of cosine starting up on the y-axis, it's going to start up at the new start. So up, middle, all the way to the bottom, back to the middle, up, right? And then middle, and then back to the bottom. And then over here, same thing. From the top, it would have to be middle and then to the bottom. And you can see that I start and end at the same spot, which is, oh, sorry, should have made that a dotted line, right? Make that a dotted curve because that's not what I'm actually trying to graph, right? So after all this, in green, we'll go ahead and graph my, my secant curve, right? Anywhere that this graph is at sea level is where I'm going to have a vertical asymptote. So the red is not a place I have a vertical asymptote. The red was just new start, right? So vertical asymptote, and then one last vertical asymptote, right? And then I'm going to go ahead and draw the shoes, right? That's a half a shoe because of the way that the spacing worked on this graph, right? And then a hat, and then a shoe, and then a hat, and then a half a shoe. And you'll notice that that half of the shoe meets with the other half of the shoe to make it a full period, right? Okay, so that's my graph. Let's do one more, and then we'll stop this video and go on to a video about tangent and cotangent. So again, what I'm going to be looking at is y equals sine of the quantity 2x minus pi. I notice right away that sea level and amplitude are normal, right? So sea level is 0, the amplitude is a 1. That's a boring regular graph, right? That doesn't involve any changes of anything at all. So that's my sea level, my top, and my bottom. Nice and easy. But the period is going to be 2 pi over 2, which is pi. And the phase shift, c over b, is going to be a negative pi over 2, which means pi over 2 to the right. Well, if I put these values on, if I put a pi over, if I put a pi as the period, right, pi and negative pi, cut it in half, cut the halves in half, well, that half is going to be a pi over 2. So what that means is 2 hash marks to the right. So my start, right, so I'm going to move my start 2 hash marks to the right, and this will be my new start, right? I also noticed that this is a positive sine graph, so it's going to start at the middle and go up and then back to the middle, and I can fill in all these other dots as I go, right? I'm just working my way backwards, and I start and end at the middle, which means I did something right. So this is my sine graph. Again, that's not the graph you were asked to find, right? In green, the graph I was asked to find is going to have a vertical asymptote at all the spots where this graph is at sea level, right? So here, and the same spot as the red line, and also this spot. So then down here where I have one of these valleys, right, I draw, I should try and make them touch. If I don't, I just kind of fix it with my pen. That's okay. Up here, I have a hat. Back here, I have another shoe, right? And then up here, I have another hat, and you can see that that's 2 full periods. And that is it for that video.